Welcome back. Today we are going to discuss similar polygons and their properties. Similar polygons are polygons that are the same shape, but they're not necessarily the same size. You can see an example of similar polygons here. This polygon ABCD is similar to polygon WXYZ. We can write that like this. With these polygons, all the corresponding angles have to be congruent. So angle A corresponds to angle W, just like with congruent shapes. This similarity statement is written in a specific order. The first letter corresponds to the first letter in the other shape. Those two angles are congruent. The same thing goes for every other angle. Now, the corresponding sides, they are not congruent, however, they are proportional. So if we look at the corresponding sides, such as AB and WX, they are proportional to every other corresponding side. So if you look, AB is divided by 3 to get WX. In other words, it's multiplied by 1/3. We can do the same thing for every other pair of corresponding sides. 12 is multiplied by 1/3 to get 4. If we are looking at this, we can find the similarity factor by looking at a pair of corresponding sides. So for example, AB over WX, that gives me 15 over 5. Another word for this is sometimes called scale factor. We can reduce it to 3 over 1. This shape is 3 times smaller than this shape. Let's use this in a problem. It says, if triangle FGH is similar to triangle JKL, list all pair of congruent angles and write a proportion that relates the corresponding sides. So this is given in a specific order to tell us what angles are corresponding. I know every pair of corresponding angles must be congruent. So angle F corresponds to angle J. That means that they are congruent. Similarly, angle G and K correspond, so they are congruent. And also angle H and L correspond, so they have to be congruent too. You can list that on your polygons as well. Now let's talk about the sides. So if I look at these sides, from L to J corresponds to HF. What that means is I can write HF or FH over JL. That has to be in proportion to every other pair of corresponding sides. KJ is corresponding to GF. Now you need to be careful which you put in the numerator and which you put in the denominator. Since I was using triangle FGH in the numerator, just like a proportion, I have to be consistent. I have to keep triangle FGH in the numerator. Similarly, I was using triangle JKL in the denominator, so I must keep triangle JKL in the denominator. Finally, GH corresponds to KL, so I know that their ratio is the same proportion as the other two. Pause the video and try the same practice problem below. Here's the correct answer. Now we will work on determining whether two triangles are similar or not. So in order for these triangles to be similar, all the angles have to be congruent and the sides must be in proportion. So let's check, are these sides all proportional? So let's find a pair that look like they would be corresponding. I see that angle N and R are congruent as well as Q and S. So what that means is that NQ must correspond to RS. So I'm going to see what is that ratio, 12.5 over 10. Now I want to see, is that proportional to another pair of sides that I know are corresponding? I'll use this pair since I see this is not a decimal. NP corresponds to RT. I know that because N and R are congruent angles. That means P and T must be congruent angles as well. So I can add that too. Now I want to see, is 12.5 over 10, is that the same ratio as 15 over 12? Again, notice that I use these in a specific order. This is triangle NQP in the numerator. This is triangle RST in the denominator. Now I want to see, are these equal? Let's try to reduce them. 12.5 over 10 can reduce to 5 over 3. Sorry, 5 over 4. Similarly, 15 over 12 can reduce to 5 over 4. If you're confused on how to reduce this fraction, I would suggest using your calculator. Type 12.5 divided by 10, and then change the answer to a fraction. It will give you 5.4. Sorry, 5 over 4. Since these two are proportional, it means that the triangles are proportional. The sides have the same proportion. We can check the final pair of sides as well. I need to stay consistent and keep triangle NQP in the numerator. So I want to see, is 11.5 over 9.2, is that also equal to 5 over 4? Well, if I type it in my calculator, I see that it is the same ratio. So I can explain this. Since the corresponding sides are proportional, I know the triangles have to be similar. So I'll say triangle NQP is similar to triangle. Now we have to be careful. Double check. N corresponds to R, so I have to use R first. Q corresponds to S, so next I will put S, and finally P and T correspond. So the figures are similar with a scale factor of 5 over 4. Since that's the proportion of all my sides. Pause the video and see if you can try the practice problem below. Alright, now we're going to look at solving problems using similar polygons. So your strategy is to write a proportion with the scale factor and solve it. So on this one, we are trying to find x. Looking at these figures and my similarity statement, I need to pick out a pair of corresponding sides that I know both lengths of. I see that I have CD corresponding to WY. That means this corresponds to this. I have both of those lengths. That can help me find the similarity ratio. So I can do ACDF in my numerator and VWYZ in my denominator. That would be a ratio of 9 over 6. Next, I'm going to make this proportional to a side that has x in it. I need to figure out what side corresponds to FD. If I look at my similarity statement, I see FD corresponds to YZ. I know that I have to put anything from polygon ACDF in the numerator. So I know x must go in the numerator. That leaves me with 10 in the denominator. Now this should look like a proportion that you know how to solve. Cross multiply and divide. So we have 10 times 9 and divide that by 6. So it's 90 over 6 or 15. So we get x equals 15. You can double check, is 9 over 6 the same ratio as 15 over 10? Yes, they both reduce to 3 over 2. Next, we'll do the same thing to find y. We already know the similarity ratio is 9/6, but we have to make sure we stay consistent with our numerator and our denominator. If you mix them up, you will get the problem wrong. So we have to double check where is y? It is on side ZV. So double check, what does ZV correspond to? It corresponds to FA, which I know has a length of 12. So I will put 12 in the numerator because it comes from polygon ACDF. I will put 3y minus 1 in the denominator because it comes from VWYZ. Now I have a proportion that I can solve by cross multiplying. So I have 9 times 3y minus 1 must be equal to 6 times 12, which is 72. Distribute your 9. Add 9 on both sides. And finally, divide both sides by 27 to get y equals 3. You could plug this in to double check if the sides are proportional. All right, I want you to pause the video. There's a practice problem for you below with the triangle. I want you to find the values of x and y. Here are the correct answers. Next, we will talk about the perimeters of similar polygons. You need to know this. If two polygons are similar, then their perimeters are proportional to the scale factor. So let me show you what that means with this example. Use scale factor to find perimeter. If ABCDE is similar to PQRST, find the scale factor of ABCDE to PQRST and the perimeter of each polygon. So we want to find the scale factor of ABCDE to PQRST. So what we're going to do is put ABCDE in my numerator, PQRST in my denominator. So I need to find a pair of sides that are corresponding. I know, before I even start this, that I have some congruent sides here. So I know CD is 4, I know AE also must be 4, AB is 8, that means BC is also 8, RS is 3, PT must also be 3. I have enough information to find the perimeter of ABCDE, but I do not know the perimeter of PQRST. I can use the scale factor to find it though. In order to find the scale factor, let's find two sides that are corresponding, that I know the length of. I see that I have the length of RS given to me. RS corresponds to CD. So I know the scale factor must be 4/3. Now I will find the perimeter of the polygon that I am able to find the perimeter of. So the perimeter of this polygon, ABCDE, when you add up all the sides, you get 30. Now the perimeter of PQRST is unknown. Let's call it X. The perimeters have to be proportional to the scale factor. So I know the perimeter of ABCDE will go in the numerator, 30, and the perimeter of PQRST, since that's coming from this polygon, will go in the denominator, and I'll just call it X to make it easier. Now you should be able to solve this proportion by cross multiplying and dividing. So we'll have X equals 3 times 30 divided by 4, which gives me 22.5. Hence, the perimeter of polygon PQRST is 22.5. Let's circle everything they asked us for. The perimeter of ABCDE is 30. The scale factor is 4/3. And the perimeter of PQRST is 22.5. If we had units, we would need to include that on each of our perimeters, but this problem did not give that to us. All right, I would like you to pause this and try the practice problem below. Here's the correct answer. Finally, I need you to answer this question. What is the difference between similar shapes and congruent shapes? Are all congruent shapes similar? Are all similar shapes congruent? Please explain your answer in 2 to 3 complete sentences. Tomorrow we will be back with drawing dilations in the coordinate plane and talking about how that relates to similar shapes. See you then.